Hi, my name's Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So today we're going to have a look again at this sample from Bin-Juine Huang, the DHX-2 collapsed pipe from the 210B reactor that I received on the 29th of December 2023, and we are going to be looking at that on this thermoscientific Phenom XL large stage SEM. So we can see it here in the center of the stage. This gives us a color overview, which we can use to navigate around the sample. Definitely cut a channel out of here. Incredible. Now, is this the dead item here or that end? Well, we'll change our focal plane back down to this one. Have a look at that first. Then we'll have a look at this end up here. I'll do a mid-focal plane as well. Actually, it might have already done that. Definitely got a curved cut out of here. A discrete curve. Interesting, look at this. It's got this lattice framework here. Let's go into that. We have seen this before. Yeah, this might be a braided section, up close and personal. See how hard lined that wall is of this channel. Very, very discreet. Okay, this kind of settles it for me that when these structures, and in fact you can see one of the little substructures here. Wow. Incredible. So when these little substructures go and chew their way through a particular material, sometimes they can leave these braided sections behind. That is a beautiful piece of data there. Now, let's see what it was at this end of the channel. Is this part of the bit that came in, or is it as it came out? Okay, so we're going to look for other examples of the interaction of these structures with the substrate. Be interesting to see if there was, more interaction with the fractal substrate. This would explain the observations by Matsumoto and also by ourselves and by Dr. Alexander Parkhomov of his strange traces. Yeah, so for me, that is just wonderful there. That area there. It's very subtle, actually. That area there with the interwoven, here we can see that it is these structures that produce these braided aftermath. And it's there in the channel, and we see the little guy that probably was part of doing this work. Let's just get that guy just full on DSD so you can see, okay, there we go. As he died, he left his carbon splodge there. Take one of that. We'll do one full. That's no good. contrast. Look at this braided pattern here. Okay, I'm really excited to look for more examples of these. Amazing thing. Look at it. It's coming under there, going over there. This is coming under there, braided. It's essentially eating the material, and as it does it, it's spitting it out and just blending it. Oh my God, it's just amazing data. I'm going to put that on SED so we can see the geometry here. Ha! That is just spectacular. Okay, look at that. Look at that. I'm going to add that into my places I want to keep. So save position there, please. So I think I might want to do a 3D look at this. I think that would be a good plan. Brighten that up a little bit. I'll take a stupid... I've done it again. Come on, here. Just pull out a little bit because we're going to go into that with super high res. Okay. We'll go there, we'll go there, and this is going to be a stonking image. Do you want to see something amazing? This substructures of this material, it's come through and it's cut this hemispherical section out of the copper oxide, and it's braided the structures, and this is one of the substructures that's done it. Mm-hmm. It's just absolutely amazing. We've actually got these on video, anyway.
Really?
Yeah, doing this, but not on the metal, but in free space, okay, spinning around each other. It's just amazing. Okay, I'm going to do a 3D structure of this so that it can be understood in more detail. This is absolutely spectacular. This is awesome! Yeah, so this would explain all of these strange radiation tracks. And you can understand that these blighters are pretty intense little creatures. They like eating this stuff for breakfast. Wow, what a beautiful image that is. Whew. Look at that. We're going to find other examples, but that's my first thing. So we are going to do a scan here. Oh, look at the braid on that. So we're going to call this oh, look at that. You can literally see where the structure died. You can see the braid on. You can see the deepness of the channel here. Look at that. I'm going to delete some of these things. Right, look at that. Oh my. Look at it. If that's not conclusive evidence of two things orbiting around each other, capturing material, spewing it out the back, blending. Oh my God, this is happening throughout nature, and it's blending material together. It is weaving a tapestry of matter. Incredible data. Oh, look, you can even see the dimple in the donut here. Whoa, okay. I've got to try and remember how to delete these things. That is the 3D view. What's that? Okay, that is, I think, adjusted for. Okay, so that is the relief view. So it's normalizing it and showing you the actual channel depth. Okay, so We're going to find out all kinds of information. It's consistent between here and here. So we're going to find out how deep that channel is. And see, note it's deep and then not so deep. So, you know, that's reflective of the 3D nature of this orbiting structure. So we're going to do one line across here. Yeah. We'll do from outside. You see it's thrown material up on the edge. So it's got a ridge. Okay, so that's kind of across the path. Look at that. It's gouged. What is that? It's gone from, okay, my whole distance there is 15.2 microns. Half of that is 7.6. So is it 10 microns across or whatever in the middle? Maybe. That's the ridge height. Okay. The base level here is at, let's say 90 nanometers maybe. And then it's gone down 1,150, let's say 1,160 nanometers. So 1,000. What is that? Is that a micron? I don't know. Look at that. That is deep. Now, is it similar up this end? If you do a similar kind of cut across the channel here. Oh, look at that. That is incredibly consistent. That is incredibly consistent, okay? Try and make them the same width. Okay. Whoa. Look at how consistent that is. That is stunning. Incredible data. Look at that. Right, well, we're going to go across the braids, aren't we? We have to. So, where should we do it? We need to find the width of the braids, don't we? So it's kind of like, actually, we just do that and get the width of the braid. I turn off the other ones here. What am I doing here? Doink, doink. We don't need that one. These are our two tunnel edges. So look at this. That is around about 2 microns wide, the substructure here. 2 microns. And it is going up from roughly, let's say, 40 down to, so it's 340 or something. It's not seeing the whole thing. Right, we'll also do a look at the actual disk itself, which I think we can probably go from about there to about there. That's about 3 microns across there. Okay. And the ridge here, the material that's kind of thrown up across there. Look at that. I'll get rid of this one. So that is about 350 microns. This is utterly insane levels of understanding of what's going on here. For me, seeing one of these structures as the actor that has done this braiding of part of a collective structure, it settles the debate for me on what is acting and producing strange radiation, and I'll leave it to you to consider what the implications are of something like this going through material. But it's definitely something to be considering when producing reactors. Look at that channel. That channel is totally consistent. Totally consistent. One peak to peak, basically, like that. So, yeah. It's kind of like 700 and what? No, it's about 700 and something microns from there, kind of there to there. Yeah, difficult to get it precisely, but that is one big trough. Look at that. This is gouged a valley out of this structure. Okay, so I'm going to leave these. Is it that one? No, that one and that one. They are the money shot in terms of this oval structure, and we are going to save this. We are going to save this. Yes, we'll have all of that. Save that all. What a pleasure and what an honor to be studying this sample. This is the signature of strange radiation. Yeah. And it's just the different clustering and substructures that result in the different patterns. There we go. So we'll close that one down. That is our braid. And we'll try and take a bigger view of that area. What an amazing thing that is. What an amazing thing. So looking at this now, it looks like this might have been the one that did it. And it's got the ejector here of some material. And it's got a hole in this side, and that might have been the one that came out from here. I don't know, I'm speculating here. Whatever. This is incredible data. Incredible data. Look at how this has just eaten this section. Showing, in my view, the responsibility for doing the damage here. Okay, this is going to take a bit of time because what I'm going to do is currently I'm focused somewhere down here. I'm going to move the focus to here, maybe here, and maybe here because this is on the angle of the sample. And I'll need to stitch these together, but wow, what a pleasure and an honor to be looking at this. I suspected that these were things that were going on for a long time. This explains the diamond-like lattice structure in the Vega experiment of Henk Uren. It explains the silver structure in the Suhas-Ralka experiment. This explains the silver-rich structure in one of my ultra experiments. It explains the cut marks observed by Dr. Alexander Parkhomov, by Takaaki Matsumoto. Oh my God, so much is answered by this one image. Or rather, it's now clarified. It was the suspicion, but now you can literally see it at work. Can anyone be in any doubt about the reconstructive capability of these little things? The way they can tear through metal and mix it up and transmute it. And bearing in mind in the Vega experiment, when we see these things flying through the air and orbiting around each other. Wow, wow, wow. Actually, looking at it from this distance, it's almost like it did this job here, and when this one disrupted, something came out here and did a helical braid here. This here looks like another helical braid. Wow. Oh my. Or maybe, here's a thought, it was something traveling here and interacting with this one that then caused the disruption. Maybe it was traveling this direction, I don't know, but these things will be answered in time. Just amazing. When I saw it on conclusive evidence that these structures can essentially instantaneously chew through solid metal and metal oxides and pass this material in a fluidized but not molten state through the center of them structures, the substructures even, and deposit it again, and it almost instantaneously solidifies. It's mind-boggling, the certainty of this data and what it is showing us. So yeah, I'm going to take one more image after this. So essentially this has taken like 14 minutes to capture, when I've done the next image after this, about 15 minutes to capture 4 8K frames, which I will then overlay in a stack focus to produce a incredibly accurate representation of what nature is able to do. And anyone watching this is going to be the first people to see this new phenomena. Not new to nature, but new in the modern era, at least in the public sense. Yeah, we've got the mid to near field in focus. I'll take this near field as well. Yeah, given the fact that this is not very deep here and it comes out and ends up here with something that's about the dimension of this, I think that that is actually how this occurred. It came in here, and that would make logical sense that over here it was starting to destabilize and it was chucking out material. So it's literally, as I said in Sochi in 2018, when I was reviewing the 20 micron cut all the way down the quartz of the LENR reactor. And if you recall, I was saying it was like and I was saying it consumes so much and then it kind of like destabilizes and then it effectively defecates. And I think what's happened here is it's defecated, but for some reason something spat out, and we'll have a closer look at this. But I think this also then broke down and spat out this helical beam over here. And then it got to this point and it kind of like jumped out, or rather it was going away at an angle, and then it dropped down here. So we'll do one more focus point over here, then we'll do a close in on this area here, and then we'll do another close in on that. You can always get what you want. You can always get what you want. But you can try sometimes. You just might find you get what you need. Yeah, so definitely we're going to look at the braided substructure coming out of here. And this might just be ejecting its payload in the same way that this structure ejected this part of this payload. What a complete honor. You understand, we're at the beginning of a new industrial revolution, or I don't know, understanding of how to manipulate matter. Oh, it's really amazing. Okay, so let's go and look right at this now. Coming out at that angle. Don't think we need to do that at 8,000 because, well, over there. Yeah. What I will do is I think this is mostly on SED. I will switch to BSD, get a better idea of the elemental composition, then I'll switch back to go and have a look at the other one. Sorry guys, you've been caught in the act. Caught in the act. Not a secret anymore. Yeah, so this is on SED. I'm going to put this over to BSD and we'll see. I'll change the brightness here. Yeah, it spewed out a bit of carbon there, isn't it? Now, is that the best focus we can do? Yeah, you can definitely see it spewed out a bit of carbon there. Oh, it's lovely. Look at that. Ha! Just beautiful. Just beautiful. Is there any doubt? Is there any doubt? On this machine because the EDS is not working today to focus on geometry, and that's not such a bad thing. Look at that. All right, we'll go down and we'll look at this one with the same detector. We'll keep the back of the channel. So this is the back of the channel. We'll keep that in shot so that we can see. And we will go here, we'll go here, and we'll get it's like it's got to here and it's like jumped out and crashed down on here. I will change that to a mix. We'll do a different adjustment here. We'll do one shot like that. Take a 3D shot of this area as well. Yeah, okay. Try a full-on SED here. Object scan of this. Okay, so we're going to go and do this geometry area here. Can I change the size of that? Oh, it's not really ideal, is it? Maybe you can do a diagonal on that. Let's go back to here. We'll do a rotation. Like that, maybe. Is that too much? Move it back a little. That's too much. Let's see. Yeah, that's got everything we want. You can get the diameter across there. I just want to, I'll rotate it a bit more. Slightly. No, not that. Okay. Can we do it? No, a bit more. No, not 12. I want 3. Come on, give me 3. 3. Is that only going to go in steps of 2? I need a better mouse. 4. Let's see what that works. Maybe even more. 5. Yeah, okay. We'll run with that. Here we go. Oh, stop it. So this is, I call it trench and cutter. Okay, let me view like that. Okay, there is our structure here. That is the thing that did the cutting. That is the hole in it. That actually is the pole. So it'd be worthwhile doing some study on some of these things to actually get a little bit more understanding of the geometry. I don't want that. Goodbye. Okay, so let's measure across our structure here, roughly across there. Nearly that. That is just a 5 micron one, right? So this is a small one. And so this will be the wheel within a wheel, and the other one that we saw earlier would be the wheel within a wheel within a wheel. So this isn't even the big boy. This is a substructure in its own right. Yeah, around 5 micron. If you go across there, maybe get the center point here. It's around sort of 5-6 micron. There. With that, the little apple thing in the middle there. Yeah, basically. Ken Shoulders, you were right. There we go. And from about here to here, there we go. There's your trench. And your trench is going down about as much as your structure is going up. I rest my case. So I think that this one here this structure here did this consumption. It skipped there for some reason. That D point's there, isn't it? Yeah, look, there's the ridge. Go to the center point, pull down from the ridge. Yeah. I think that, my friends, is the structure that consumed that, and it's buried itself a similar amount into the material. There is some ejector of carbon there probably, and I think it lost one of its structures in that last interaction. Just for the sake of argument, I'm going to turn those off, and we'll see the kind of distance between here and here that it jumped. Yeah, so it jumped about 7 microns, 6.5 microns. Basically its own diameter and a little bit more. Okay. That is awesome. Thank you very much, Bin-Juine Huang. And thank you to the donors that made this session possible.